not long ago I picked up a Heathkit GC1005 Panaplex, which is a plasma display clock, to replace the one that I built when I was a teenager and it's long gone. Anyway, I recapped it when I got it. It was working fine, and now, well, check this out. Well, this is my Heathkit, and as you can see, well, it's not working properly. It's developed a problem. It's stopped. If I give it a tap, it starts working again. So, I do believe that this unit has a small problem that we're going to have to look at. Interesting. I've noticed that this has done it a couple times before, and it is intermittent, so I haven't bothered to do anything. I rebuilt this one a while back. I replaced the caps in it when I got it. This is a replacement for the 1005 that I built when I was a teenager, and I think I've talked about that story before. Originally, when I was about 12 or so, or 13, Radio Shack came out with a digital clock that was it was based on a MOSTEC. I think it was a 50250 clock chip, and they sold the board for like $2.50 for the circuit board, but you had to buy all of the parts to make it. And when I was a young teenager, I wanted to build this thing. So I'd asked for the kit for my birthday. Of course, my dad, knowing nothing about electronic circuits, went down to the local Radio Shack to try and buy it, and the guy basically said, well, here's the parts list, go find all the parts. So my dad, not knowing anything about electronics, because he was a longshoreman, so he knew nothing about electronics, he threw his hands in the air and marched off to the Heathkit store down on Kingsway, when it was there, when we had a Heathkit store, and purchased me one of these as a kit, because it came as a full kit with case and all the parts. The mistake I had making the unit was that I used the wrong type of solder when I put it together, and I used acid core solder, and well, the results were predictable. It died shortly after that, and it never got repaired. I don't ever know what happened to it. It probably got thrown out. But I found this one, and I picked this one up a while back. I've been keeping my eyes open for one that were in good shape, and I picked this one up, and the first thing I did was I replaced the two main filter caps in it, just so that it'll last a good long time. But as you can see, it was stopped there. So we're going to take this into the shop. We'll go over the circuitry and see what's causing it to stop like that. The fact that I can give it a tap and it starts working again, to me tells me it's a bad connection somewhere that is preventing it from working. Let's take a look at it. So I've got the schematic here, the basic schematic. I haven't put the two sides together, but you get the idea. This one here, it printed on 2 pages. This one here is just a display driving circuit, so we don't need to really worry about this one. This is the one that we're interested in. This is the one with the MOSTEC. This is an MK5017AA. And how these chips work, this was one of the first, if not the first, all clock on a chip, single chip solution for making digital clocks. The single chip contained the countdown as well as the counters for your hours, minutes, seconds, and your countdown. And how they work is they are referenced off of the AC power. So your AC from the transformer comes in here. There's 2 power supplies for this one, because this particular type of clock uses a high voltage display called a Panaplex, which is a plasma display. It's a cold cathode 7 segment neon display is what it is. So there's 2 separate windings. There's a high voltage winding here, which generates about 170 volts or so for the display. I guess what does that say? Is that 170 or 120? 170 volts AC right there. And then there's the low voltage supply, and the one that operates the clock is the low voltage supply, which is this winding here. Right, my pen is running out of highlighter, but so how the clock works is that you have a half-wave rectifier here and a main filter capacitor, and then it goes through a 2700 ohm resistor, and then there's a Zener diode here that clamps it at 15, I think it's 15 volts. And that's applied to pin number 1 of the main IC. There's a second sample taken from the transformer, and it goes through a half-wave rectifier as well. But this one's not filtered by a large filter capacitor. This one here goes straight in, goes through a resistor, another resistor to pull it to ground so that the only one half of the waveform will be present, and that goes into this pin here. Was it pin 23? It looks like. Not a good print. And what this does, this is the basically a 60 hertz pulse, and it's debalanced with a little 0.022 microfarad capacitor here. This is just to clean up the waveform a bit, but basically what the chip does is, as the pulses come in, every cycle of AC, this diode here is going to create a waveform like this, like it's shown here. So you've just got one half, and what this does is it counts the pulses, and every time it counts 60 pulses or 50, depending on whether you've got the 50 or 60 hertz switch set on the chip. Every time it counts 60 pulses, then it knows it's 1 second. So therefore, if you lose this pulse, the clock is going to stop and it's going to freeze, which is exactly what it's doing. So that symptom of the clock stopping tells me that the problem is right in this circuitry right here. We have a connection problem, and the very fact that I can tap the board, tap the whole unit, and it starts working again, is telling me that we're losing that pulse. It's either at the diode here, or it junctions in off of the transformer, or it could even be on the chip. That's what I think the problem is going to be on this clock, because these things are not that complicated. So let's open this one up and take a look inside it again. Looking for my little red handled screwdriver. I know it's here somewhere. There it is. So as I was saying before, this was not this particular clock, but one just like it was the first digital clock that I built. And it was more by accident, because I had always wanted to build the one that Radio Shack had advertised, because that was the first one that I was exposed to. You know, I used to go into Radio Shack and build those little P-box kits, and then a number of the little project board ones. I built a few of those. I think I built the single digit counter. I think I've still got that one kicking around somewhere. It just counts when it counts a pulse and gives you a 7-segment readout. And I think I built a phono preamp or a little 2-watt amplifier. I built a few, but I always wanted to build the clock. And as I was saying before, when it came time to actually get it, my dad knew absolutely nothing about electronics, and it was I guess it was just the fear of not knowing what to buy. So we ended up down at the Heathkit store, and I knew nothing about Heathkit at the time, and I'd never been there. But one that caught my eye that I really wanted really bad, which I didn't get, was the most accurate clock, which would have been I think that was the CG1006, the one that had the shortwave receiver. I wanted to build that one. I was told no. This is the one that I got, or one like this that I got. And I'm sure that if I still had it, the wiring that I put in it was probably as messy as this, if not worse. As I say, mine worked for a while, but unfortunately I made the mistake of assembling it using plumber's solder, because that's all that was kicking around the house. Stuff that my dad had from when he'd been working on copper plumbing. And that's the stuff that you put the solder paste down and stuff with, but it had an acid core. And, didn't do a good job on any of the parts. The board was attacked, and that was the end of that clock. So while I work on this, I have to be really careful of these Panaplex displays because they are made out of glass and they are rather fragile, along with everything else that's on here. I got one more screw to take out here that holds the display board. Oh no, it's this one over here. I'm going to unsolder the speaker wire here just so I can get the board out of the way and look on the bottom of it for any failed connections. We'll make sure that the chip is pushed all the way down. Oh, it wasn't all the way down, so that I might have just reseated it. I may have just fixed the problem there, pushing that MOSTEC chip a little further into the socket. You gotta be careful with these MOSTEC chips though, because this is a ceramic chip. There's actually gold in this. These are gold plated pins, but there's actual gold, quite a bit of gold in one of these chips actually. They'd be way too expensive to manufacture today on this design. Because I mean, this is gold. You can see the gold plating or the gold leaf on here that even connects the top shield cover of the chip here to ground. So I'm just waiting for my iron to warm up a bit. But I remember putting one of these together. It was a lot of fun. You had the step-by-step manual. It had all the locations of the parts, and the value of it is also silk screened onto the board. So it made assembly actually quite easy. And the manual would tell you which wires to put in. Like they had these little wiring harnesses that would say, brown, red, orange, yellow, and it would tell you which letter went to each color on both of the boards here. So it was a relatively straightforward unit to do. I was just always disappointed because, of course, back in the day when this was around, we didn't think of the Panaplex displays as being really cool because they were quite common. Calculators and everything had these. All the cash registers had these. Pinball machines used them. At the time, I would have thought, this is old technology. LEDs were cool because they wouldn't break. These are glass, right? And LEDs would never fail. So the LED displays were the cool ones, and these ones here were kind of like, So when I got my kit, it was always one that I wasn't. I would have been more fond of one if it was LEDs at the time, just because LEDs were so new. Of course, the opposite is true now. LEDs are a dime a dozen, and these are actually quite rare. So today, it's all about preserving the old technology, right? But back when these were new, well, it didn't do a heck of a lot for me because the one I really wanted to build was an LED clock. But as you can see, this one here has been constructed properly. No acid solder on here, but I'm going to take a look at all these solder connections on the pins, and in particular, what was it, pin? What did I say? It was pin 23. So if we take a close look at the board, pin 23, which is the pulse input, is this one here, because there's pin 24. So pin 23 is that one. I hate it when that happens. This is our pulse in, and we follow it back, and it'll come down to here. This is going to be our diode and so forth down here. If we look down here on the board, I don't know, maybe shining the light on it's not good for the camera, but it certainly helps me see it. But that connection right here, see if I can get the camera to behave a bit and focus a little better. That connection down there doesn't look to be really good. You see the one I'm referring to, which is these ones right here. I don't know, those look pretty flaky. I think a good going over these solder connections here will go a long way to increasing the reliability of this clock. So that is what I'm going to do. I'm going to go over those connections. Gotta love this little barrier that goes in place just to protect the switches from shorting things out. I'm going to go over those connections starting, I'll go over them all because, you know, they all look like they could probably use a bit of work on them. And it was done by who knows. So the quality of the construction on this here may not be up to what I would consider to be good standards, but I'll start at pin 24, which is right here. Get my iron nice and clean. Or sorry, pin 23. What am I saying? Pin 24 is here. These are the ones I suspect, like this one. See if we can get the camera to focus a bit better down there, because I'm in manual focus now. I'm in relatively close, so it's hard for the camera to focus. Let's finish up the bottom part of the chip here. Looks okay. Like this insulators, right? Just a piece of cardboard to insulate the high voltage from this thing from shorting out. Oh, one of my ground wires came off. Reattach that. My cat's talking to me, howling away. So we'll plug it in, and that is normally how they do start up, because we have to set the time first. How we set the time on this is we flick the switch on the bottom to time set. There's 4 switches on the bottom. The switches are as follows: time set, alarm set, I think it's minutes and hours, and if you hold the 2 switches together it becomes tens of minutes. So if I switch the hour setting, and this little neon light indicates AM, so if I want to set it to 3 p.m. I flick the hour switch and I roll it ahead to 3 p.m. There's 3, and I want to go to 12. So if I flick the next switch up, it'll do 1, 2, and if I want to go to 12, I flick both switches. There we go, 12. But I want to go to 13, so I'm going to go to 13. I'm going to wait for the time to catch up to 13, which I got to wait about 8 seconds, looking at my CRT clock right above me. And then as soon as it gets to 0, I'm going to flick this switch. So 59, 13, and then it starts counting. And that is how this works. And hopefully that's the only problem. My ground wire broke off again. I'll have to resolder that before I put it together. But hopefully that's the only problem with this. I got another problem with this thing. Watch this. When I tuck on the fuse, I got another connection problem in here. Yeah. What else is wrong with this thing? I would imagine that this is, oh, I can see the problem right here. See the problem? Solder connections, construction problems. It's, yeah. The fuse is not attached. I should check these other connections out here too, because I didn't go over this when I got it. I just changed the caps on the stupid thing when I got it, right? But, I didn't go over anything else on this unit. So this just powers off. Yeah, great. This is why when you buy something that somebody else has built, it's always a good idea to give it a full go over. Look at the AC cord down here. When I got it, I only was concerned about changing out the caps on it. I also made a permanent connection for the transformer because they had little clips that were basically just stuck over the little pins. So I wanted to make sure that they wouldn't come loose. So I soldered them down, but I didn't check these big connections down here. This one here is also bad. And this is something that disturbs me because the AC is so close to each other, but that's okay. With the covering on the fuse here, it's not going to be a short circuit hazard, but still. Make sure that that's well attached to the transformer wires. And we'll do the same on this side of the fuse. Okay, now that should hopefully not cause me to lose power again. I was wondering what was going on there. I was looking at it, I was talking to the camera, I looked, and the display was out. What the hell? It was working, what the heck happened? Okay, let's try powering it up again. Okay, now we have power. We'll reset it again, and I'll reattach that ground wire. So there's our time. Hours. Okay, and now even though it's running, I can set the hours. So if I click the hours button here, there we go. Now we're set. The AM indicator only lights if you're in what they call the hold mode, which holds the seconds at 0. The second switch is used to set the alarm. So if I flick the second switch, it'll go to the alarm time, which is 12 o'clock. If I want to set the alarm to say 3:23, I could just go on to, oops, 3:23 I'll go to PM. And then if I flick it back, if I turn the switch on the back here for the alarm, it'll buzz when I get to 3:23. It'll start to buzz. This button, or this switch here, is a 10-minute snooze, and of course we switch this one off to turn the alarm back off. But that's the function of the clock. Now that I've fixed these solder connections, I wonder how many more of them are going to go bad on this thing. But now that I've redone the solder connections here in the reference voltage and found that the fuse and the line cord wasn't soldered in properly, that may have been causing the problem too. It may have been intermittently losing connection and causing noise to appear, and noise could have caused the thing to stop as well. But that is... yeah, that was just bad construction on the original builder of this, which I have no idea who built this because I bought it off eBay. As I say, I wish I still had the one that I built so that I could show you guys how bad it was. But more importantly, I wish I still had it because the Panaplex displays on mine would be almost new, because it was maybe only ran for a year or two, and then it started to act up. I started to lose like digits and segments and stuff, because I'm sure that when I got into it to look at it, all the transistors here and so forth, all the solder connections on the back side of the board here, where all these parts were, they were all starting, like all down in here. It was all corroding from using acid core solder. It was an important lesson to learn about solder. But when you're 12 or 13, you don't really think much about that. And what's crazier about that is that my first electronics teacher, when I got into junior high, he was having us put together our little projects when we started building projects. I think it was grade 8 or grade 9. we were putting together little projects, and he was having us use the Kester solder paste that you would put on first, like the type that plumbers would use. The same crap that I put on my 1005 kit when I built it, because, hey, that's the way we had all been taught to solder, right? You had to put solder paste down first, and now we use liquid rosin flux. But back then, we didn't use flux. We didn't use rosin flux. We used what they sold at the hardware store for in the plumbing supplies place, the plumbing supplies aisle, which was acid for cleaning pipes. Anyway, let me get this unit back together. This has become one of my favorite clocks now, because of the rarity of these displays. So I want to get this back together and get it back in the house, and then we'll finish this one up. Power off. That's how you can generally tell a fairly good Panaplex display as well. When I turn off the power as the displays fade out. Power off. See, they're all fading out roughly the same. If you look at the displays, so you can tell which displays have got the most hours on them. These ones here and the hour. The tens of hours doesn't have as much. Like, you can just see a slight darkening of the actual glass, ever so slight. You can see it probably on camera, but that's just the actual glass itself. That's just from the hours. This thing's got thousands upon thousands of hours on it, I would imagine. But hey, the display is still working. You know, the brightness is pretty equal between all the display segments. It's looking good. I think this clock makes my collection of digital clocks, electronic digital clocks, pretty much complete, because I've got all the types of electronic digital clock displays. I've got 2 Nixie clocks that I built, and I've got there we go. Set it. I've got 2 Nixie clocks. And and 3 vacuum fluorescent. These are ones that I built, right? 3 vacuum fluorescent displays that I built, and I've got Numatron, LED, dot matrix LED, as well as 7 segment, and I guess that's about it. Oh, and then of course the CRT, but that's just using that's kind of cheating for that one. Oh, and the oscilloscope CRT, the oscilloscope clock. But as far as the digital displays, I've got everything covered. I've got Panaplex, I've got vacuum fluorescent, I've got Numatron, and I've got LED, and I've got Nixie tube. So I've got all the types of digital readout display clocks with electronic readouts since the development of the technology. That's my collection of digital clocks. Thanks for watching. We'll catch you in the next one real soon.